So, my AET Techtalk for the AD subject or the analog and digital electronic is twinkling light emitting diode. And my name is T. Kaushik Reddy from CSCB, and my roll number is T292295180570. So in this Tech Talk, I'm gonna talk about a topic named twinkling light emitting diode in subject analog and digital electronics. Let's start. So basically, let's learn first what is an LED. An LED is a light emitting diode. It is a semiconductor device that emits light with when an electric current is flows through it or passed through it. When the current passes through an LED, the electrons recombine with the holes, emitting light in the process. LEDs allow the current to flow in the forward direction and blocks the current in the reverse direction. So here, basically, the current in the current to flow in the forward direction and blocks the current which flows in the backward direction. Then light emitting diodes are heavily doped PN junctions based on the semiconductor materials used and the amount of doping. And LED will emit a colored light at a particular spectral wavelength when forward biased. As shown in the figure and the next slide, an LED is encapsulated within a transparent cover so that emitted light can come out. So the LED, the light emitting diode or LED as it more commonly called, is basically just a specialized type of diode as they have commonly a very similar electric characters to a PN junction diode. This means that an LED will pass a current in its forward direction but block the flow of current in the reverse direction. Light emitting diodes are mainly are made from a very thin layer of fairly heavily doped semiconductor material, and depending on the semiconductor material used and the amount of doping. When forward biased, an LED will emit a colored light at a particular spectral wavelength. So when the light is biased, electrons from the semiconductor's conduction band recombine with the holes from the valence and band, releasing sufficient energy to produce photons, which emit a monochromatic single color of light. Because of a thin layer, a reasonable number of these photons can leave the junction and radiate away, producing a colored light output. Then we can say that when operated in a forward biased direction, light emitting diode are semiconductors that convert electrical energy into light energy. The construction of a light emitting diode is a very different from that of a normal signal diode. The PN junction of an LED is surrounded by a transparent hard plastic epoxy resin hemispherical shaped shell or body, which protects the LED from both vibration and shock. Surprisingly, an LED junction does not actually emit that much light. So the epoxy resin body is constructed in such a way that the photons of a light emitted by the junction are reflected away from the surrounding substrate base to which diode is attached and are focused upwards through the dome top of the LED, which itself acts like a lens concentrating the amount of light. This is why the emitting layer appears to be the brightest at the top of the LED. However, not all LEDs are made with the hemispherical shape dome for their epoxy shell. Some indications LEDs have a rectangular or cylindrical shaped construction that has a flat surface on top, or their bodies shaped into a bar or an arrow. Generally, all LEDs are manufactured with two legs protruding from the bottom of the body. Also, nearly all modern light emitting diodes have their cathode negative terminal identified by either a notch or flat spot on the body, or by the cathode lead being shorter than the others as the anode plus. Lead is longer than the cathode gap. Unlike normal incandescent lamps, band bulbs, which generate large amount of heat when illuminated, the light emitting diode produces a cold generation of light, which leads to a high efficiency than the normal light bulb. Because most of the generated radiates away within the visible spectrum, because LEDs are solid state devices. They can be extremely small and durable and provide much longer lamp life than normal light sources. Light emitting diodes. Uh, Here is the basic diagram, or on the left we can see the light emitting diodes, or a small bulb which produces light in the form of which produces light in the form of energy. So this is a basic circuit for an LED. So the uh, on the left it is a battery, and R is a resistor, and LED and the on that which is highlighted is LED, light emitting diode. How does an LED work? When the diode is forward biased, the minority electrons are sent from P to N junction, while the minority holes are sent from N to P. At the junction boundary, the concentration of minority carriers increases. Excess minority carriers at the junction recombine with the majority charges carriers. Working principle of LED. So the down one is the uh, working diagram of an LED, where the electrons are sent from P to N and the minority holes are sent from N to P, and which has a Fermi level and band gap and valence band. Next, the energy is released in the form of photons or recombination. In standard diodes, the energy is released in the form of heat. But in light emitting diodes, the energy is released in the form of photons. We call the phenomenon electroluminescence. Electroluminescence is an optical phenomenon and electrical phenomenon where a material emits lights in response to an electrical current passed through it. As the forward voltage increases, the intensity of the light increases and reaches maximum. Light emitting diode, uh, it is a IV characteristics. Basically, on the y-axis it is current in milliamperes, and on the x-axis it is voltage F. And these are the different rays like infrared, red, amber, yellow, green, blue, and white. And on the left, the circuit is the conventional current flow, cathode, anode, and it is an IV characteristics, basically, not VI. So before a light emitting diode can emit any form of light, it needs a current to flow through it, as it is a current dependent device with the light output intensity being directly proportional to the forward current flowing to the LED. So as the LED is to be connected in a forward bias condition across a power supply, it should be current limited using a series resistor to protect it from excessive current flow. Never connect an LED directly into to a battery or power supply, as it will be destroyed almost instantly, because too much current will be passed to them burn it out. So basically, you shouldn't directly connect an LED to the power supply or the battery, because there's a lot of current produced, so it may blast or the burnout. So be careful. Don't connect an LED directly to a power supply or the battery. From the table above, we can see that each LED has its own forward voltage drop across a PN junction. And this parameter, which is determined by the semiconductor material is used, is the forward voltage drop for a specified amount of forward conduction current, typically for a forward current of 20 milliampere. In most cases, LEDs are operated from a low voltage DC supply with a series resistors RS used to limit the forward current to save a value from, say, 5 milliamperes for a simple LED indicator to 30 milliampere for or more for where a high brightness light output is needed. Next, these are the types of light emitting diodes or LEDs. The first one is gallium arsenide, GaAs, infrared, and next one is gallium arsenide phosphide, GaAsSP, red to infrared, orange. Aluminium gallium arsenide phosphide, high brightness, red, orange, and yellow. Next, gallium phosphide, red, yellow, green. Next, aluminium gallium phosphide, green. Next, gallium nitride, green, emerald green. Gallium indium nitride, near ultraviolet, bluish green, and blue. Silicon carbide, blue as an IA substrate. Zinc selenide, blue. Aluminium gallium nitride, ultraviolet. So these are the different types of light emitting diodes or the LEDs. Next, these are the uses of LED. LEDs find applications in various fields, including optical communication, alarm and security systems, remote controlled operations, robotics, etc. It finds usage in many areas because of its long-lasting capability, low power requirements, swift support times, and fast switching capabilities. Below are few standard LED uses. So there are four standard or the basic uses of LED: used for TV backlighting, used in displays, used in automotives. LEDs used in uh, dimming of lights. Dimming of lights. Next type of LEDs. Below is a list of different types of LEDs that are designed using semiconductors. First one is miniature LED. The next one is high power LEDs, and third one is flash LED, and bi and tricolor, red, green, blue LEDs, alpha and numeric LED, and lighting LED. Next, advantages of LED over incandescent power lamps. Some advantage of LEDs over incandescent power lamps are LEDs consume less power and they require low operational voltage. No warm-up time is needed for LEDs. The emitted light is monochromatic. They exhibit long life and ruggedness. Next, here is the conclusion, or you can say the end of the topic or the conclusion for the light emitting diode. A light emitting diode converts electrical energy into light energy. A light emitting diode is a type of special diode whose PN junction is made for a compound semiconductor. The LED comprises of heavily doped semiconductor and has a very thin layer of PN junction. The forward biased LED enables the electrical electrons in the conduction band to recombine with the holes in the valence band. In doing so, the electrons release the energy in the form of photons or light. The color emitted by the photons is dependent on the semiconductor compound using in the LEDs, and its intensity is dependent on the forward biasing current. So basically, I conclude a light emitting diode or LED is nothing but which converts electrical energy into light energy, which provides a light which makes human to watch it very clearly with a good vision, with a lighting vision, with not a black vision. And the color emitted by the photons is dependent on the semiconductor compound used in the LED, and its intensity is dependent on the forward biasing current. The LED or the forward biased LED enables the electrons in the conduction band to recombine with the holes in the valence band. In doing so, the electrons release the energy in the form of photons or light. So the energy or the supply flowing in the forward direction or the forward biased, it is not blocked, as the current flowing in the backward direction is blocked. So and the, do not connect LED to the directly to a power supply or a battery, which as it provides a more current or the more energy or the supply, which makes the LED to get destroyed or to burn out. And the LED comprises of heavily doped semiconductor and has a very thin layer of PN junction. Next, a light emitting diode is a type of special diode whose PN junction is made up of compound semiconductors. Next, a light emitting diode converts electrical energy into light energy. So, and these are the advantages of LEDs over incandescent power lamps. No warm-up time it's needed for the LEDs. The time light is monochromatic. They exhibit long life ruggedness. So here is the conclusion for the LED light emitting diode. Like we already told in the previous LEDs, which converts electrical energy into light energy, and it is a heavily doped, and it is in the form of a compound semiconductor, and the LED comprises of heavily doped PN junction, heavily doped semiconductor, and has a very thin layer of PN junction. And the forward biased LEDs enables the electrons in the conduction band to recombine with the holes in the form of valence band. In doing so, the electrons release the energy in the form of photons or light. Next, at last, the color emitted by the photons is dependent on the semiconductor compound used in LEDs, and its intensity is dependent on the forward biasing current. So, next, the wavelength of the emitted color lies in the visible or invisible light spectrum. The series resistance is usually essentially to avoid damaging the LEDs, and the value of series resistance requires to be calculated depending on the LED type, number of LEDs, and their series parallel configuration. The LEDs are available in a variety of colors. The monochromatic colors are widely used and cheap, whereas bicolor and multicolor LEDs are mostly available but comparatively costly. The LED applications include, but not no limited to, indication proper purposes, displays, televisions, and large advertisement displays, etc. In LED, the monochromatic colors are widely used and cheap, whereas the bicolor and multicolor are also available but little costly, or you can say comparatively costly to the compared to the monochromatic LEDs, or the monochromatic colors widely used and cheap. So yeah, thank you. This is the my AET Tech Talk topic, twinkling light emitting diodes for subject ADA, analog and digital electronics. So yeah, thank you. Thank you.